Hello everybody. So today we're going to cover a very important concept that's high yield for the USMLE Step 1, Step 2, Step 3, and general medicine entirely. And this is going to be acid-base disorders. And this is very important, especially part of your nephrology field and all the relevant questions around it. So for the purpose of this video, I want you to keep some things in mind. These will be certain values that you can use to quickly characterize this. So it will be bicarb, PCO2, the pH, and an anion gap. So for the purpose of this video, we're going to have our bicarb set at 24, our PCO2 at 40, our pH at 7.4, and our gap at 12. So now what is acidosis and what is alkalosis? So acidosis would mean a rise in our H plus ions, a fall in the pH, a fall in the bicarb, and a rise in our CO2. And on alkalosis, we have the opposite going on. So we have a fall in the H plus ions. Our pH will be higher. As a result, the bicarb will be higher and our CO2 will be lower. So now keeping these numbers in mind, you have to think about the various variations that you have. Now then, when we go on to our questions, right? So first we start with what is the pH? We get a question, we say, okay, a patient comes in and we get an ABG done. That's where we find our values. And what is the pH? An acidic pH would mean less than 7.4, or alkaline would be more than 7.4. So that will tell us, do we have a acidosis or alkalosis going on? Now to characterize whether or not it is metabolic or respiratory, we have to look at our bicarb and CO2. How is this important? So for metabolic, we got to look at the bicarb value. And for respiratory, we got to look at our CO2 value. And on the basis of that, if we go back up to our initial table, we see that when the bicarb is low, we have an acidosis. And when the bicarb is high, we have an alkalosis. And similarly with the CO2, when our CO2 is high, we have an acidosis. When our CO2 is low, we have an alkalosis. So this is the basics behind how we choose what a certain patient has on the ABG values. Now then, the body has a homeostasis position where it tends to make a compensatory effect. How does the body compensate? We look at the certain diseases. So let's start with the first case where we have a metabolic acidosis, and all you have to do is just plug in these values. Normally what would happen in a metabolic acidosis, you have a drop in your bicarb because it's metabolic, and as a result the opposite happens, which means that your PCO2 value should also drop to compensate. And it does this by releasing its H plus ions. So to discern how the compensation occurs, we should do 1.5 multiplied by the bicarb level plus 8 plus minus 2. And this value will tell you what your PCO2 should be. Very important. What your PCO2 should be. Generally, our PCO2 should match the value that we calculate up here. And if it doesn't, we have to think a secondary disorder is there. And maybe we can cover these secondary disorders in the next video, but to keep it basic, these are the basics of it. And we have our main other types of diseases where we have metabolic alkalosis, acute respiratory acidosis, chronic respiratory acidosis, acute alkalosis, and chronic alkalosis. And as you can see, if you just plug in your values here, you plug in your bicarb, right? You plug in your bicarb, you get your CO2. Plug in your bicarb, you get your CO2. So for example, if I just teach you guys this, for a respiratory alkalosis, which would mean, what would your respiratory alkalosis be? When our CO2 is less. So our drop in CO2 by 10, every drop by 10 should also drop the bicarb by 2. What does this mean? This means that if we go up here, every drop below 10 from 40 would equate a drop in your bicarb by 2. And that's how you know that this is the process that's occurring, and this respiratory alkalosis is adequately being compensated by the reverse process. Now then, in our metabolic acidosis, there's a second thing we have to cover, which is the anion gap. And you can refer to the YouTube short that I posted above, where it tells you what is the mnemonic for these anion gaps. So for anion gap, we have to check that after we have confirmed a patient has a metabolic acidosis, we do the sodium minus the chloride plus the bicarb. And if this value is more than 12, this is a raised anion gap. And this could be due to any unmeasured anions that are present in the body, such as our mnemonic mud piles. And you can refer to the YouTube short about this, about what each anion is present in this mnemonic. I hope this has covered everything. Please comment down below what other videos you would like me to make. Thank you for watching.